All right, welcome to the first session of the second day of NDC Porto. I hope you had great dinner yesterday. And today I'm going to talk about common mistakes in EF Core. And this talk is going to be focused on some of the common mistakes that I have seen in production, a couple of horror stories that I have experienced as trying to fix some of the applications where the main takeaway from the developers was EF Core is horrible. And then I looked at it, spent an hour on it, things started to run 100 times faster, and it's like, how did you do that? And I was like, I just did do these few things. You know how you do SQL queries? If you think a little bit in that regard, you can do really good queries. So these are a few things that I'm going to show you, as well as very EF Core and .NET specific things. So first off, I am Jernej Kavka, originally from Slovenia, now living in Australia. But you can call me JK. And you can follow me on all of these socials. I'm also a host at Global AI, the podcast, and several different Australian and Brisbane user groups. I'm predominantly a .NET and EF Core developer, specializing in building web applications, console applications, and whatever the clients need me to build. But I'm also a Microsoft AI MVP, and I do lots of ChatGPT. So if anyone here is to have one good advice on ChatGPT, you're covered. All right, so let's go into intro. Then I'll go for the 7 deadly sins, the 7 things that I've seen most commonly in production and has big impacts on how your application runs. And a couple of mini best practices, because I just don't want to give you, hey, here's some common issues, here's how to fix them, but also here are some really good advice that you probably should follow. All right, so one thing that you might all of you know is there are a lot of databases nowadays. And for anyone who's not too familiar with EF Core, one of the reasons why you might want to use EF Core is because you don't always want to decide which database you want to go for. And it kind of alleviates that decision because you can start developing the application with EF Core and decide later what specific database engine you want to use. And there's also various ORMs. There's just a couple of over here, like EF Core. Dapper is technically a SQL builder plus mapper. Then we have Martin, Cosmos DB, and there's lots more of them. But the main reason why I usually choose EF Core and why I recommend people to use EF Core as one of the first options is because it gives you a great balance between features, flexibility, and performance. And it's one of the ORMs that gives you the most choice between these 3 options. So if you need more performance, there is a way to increase performance. If you need more flexibility, you have an option to have more flexibility. Usually it comes at the cost of the other 2. And it's really, really awesome for relational databases. So if your database is relational, EF Core, if you're doing .NET, is really awesome. For non-relational, EF Core is getting better and better. And I'm seeing more people now using EF Core for non-relational as well, especially with EF Core 8. And one of the big things is the built-in migration and DB scaffolding along with other tools. Because how many of you are doing database migrations? Quite a lot. For how many database migrations are painful? Okay, pretty good crowd. Usually for a lot of people, database migrations is a big pain. And with EF Core, it's usually just one command line. You check that everything is fine and just run the migration. And DB scaffolding, if you need to use an existing database, there's a CLI command where you can just generate the entire EF Core context for you. You make just a couple of tweaks, and you're done. And another thing, if you have seen yesterday's keynote, what EF Core also pretty nicely represents is the theory of cooperative principles. Basically, what that means is when you want to have a code, for instance, that concisely message what it wants to do, does only what you ask it to do, and various other things. If you're more interested in this, Eli done a talk about language games, and I really recommend this because adopting these principles, I think, will make you a better developer in terms of how you write the code and how it's understood by other people. All right. So the main part of this talk is to avoid pain that sometimes come with EF Core. So how many of you have developed EF Core and you had some pain with it? That's quite like half of the room. Well, hopefully I'm going to show you how not to have that pain, how to actually enjoy EF Core. One of the things is I've seen a lot of really badly written EF Core in terms of, here's 200 lines query, and you're like, what does it do? I was like, I don't know. Then I'm going to benchmark the queries because a lot of people don't understand what impact certain lines of code may have. And I'm going to show you not just by running the code once, I'm going to load test it. So I can show you the consequences of certain patterns when the server is already under load. Because your SQL server as well as your .NET server might behave differently under load than when you just run it once. And lastly, the horrors I have seen. And you will be able to do this on your own if you like to, because I'm using benchmark.net for memory consumption and time differences, and Bombardier for load testing. Now, this is not the best way to do load testing as overall application load testing, but it's really good way to basically test how a single endpoint behaves with or without load. And also, just for reference, this is my machine, just so that if you get really different numbers, that might be one of the reasons. RAM actually will have a big impact on performance. So if you don't have enough RAM, you may get vastly different results than I have. And most of the tests are done with .NET 7 EF Core. I haven't updated yet to EF Core 8, but I have ran the test to verify that the things that I'm talking to here is still relevant with EF Core 8. And the test data is 7 million sales. So we have a table with 7 million records, 504 products we don't use, 23 employees, and 20,000 customers. And this is important because sometimes what happens in production is your application runs really, really well, really smoothly. 3 months later, everything is on fire. And this is why I took 7 million sales, to show you that fire. All right, 7 deadly sins. So first off, IQueryable to IEnumerable. I'll show you. This is one of the biggest performance and stability issues you'll encounter. Then as not tracking, it's really good. Explicit joins. So how many of you are doing joins manually? Like you write the actual code? Not many, okay? Getting all of the columns, no pagination, that is something that when it happens in production, it slows down your server considerably, if not done properly. Non-cancelable queries and inefficient updates and deletes, which came with EF Core 7. I just went 1 second over there. I'll also provide the slides later. All right, so first off, how bad can it be, right? Writing a little bit of bad code here or there, or just doing EF Core without thinking about what actually might happen? This is usually a question you never want to ask, or at least you never want the answer to, and I'm going to show you why. IQueryable to IEnumerable. So here we have one code, and some of you might spot the problem here right away. And then we have this. This is a little bit different code, right? Some of you might spot something odd over here. And then we have this code. This is something that I have seen very commonly on a lot of client projects. So what do they have all in common? Technically, they're all the same. So this one that does to list and then count is technically the same as this one. This will get all of your data from the table. And the reason why this happens is when we do an HTTP request, and at the moment we are casting it to IEnumerable, what happens in EF Core end is says, we're casting to IEnumerable. I'll evaluate everything up to that point, which in this case means a select star from sales. That means it will get all 7 million records with all of the columns from the database. Then it's going to pass all of the data in its full glory, only to check how many of them are there. And then it's going to dispose all of the data, never actually looking into it. So what you should be doing is you should always use IQueryable. Now, in this particular case, we have a private method used inside a service or command to query or wherever you would want to use that. I have seen where developers try to be following good practices, use IEnumerable wherever they can, and they use IEnumerable in services where they should be actually using IQueryable. Now, if you use clean architecture, you might actually have different methods to avoid this issue. And what happens behind the scenes is, you can see here we have a full statement. We have sales.count, and EF Core evaluates the whole query with the count, and then generates select count star from sales, which then only returns a single integer. That's it. It doesn't return 7 million records, just a single integer. So if there's anything that you remember from this talk, is this part. But don't worry, for anyone getting bored, we're getting to a more fun part soon. Benchmarks. So the first one was about took a million times more memory. Just imagine, just counting how many rows we have in a table takes about 2 gigabytes of RAM on .NET side, not on SQL Server side. And it's 64 times slower, and yeah, it's about 3.5 seconds slower. So that's a really huge impact. And keep in mind, in a couple of years, you might not have 7 million sales. You might have 10, 15, 35 millions. This is going to scale. This is going to be bigger and bigger problem. And if your manager says, well, users can wait 3.5 seconds, this is why we have load tests. Because this is a very small load. But under very small load, those 3.5 seconds now become 33 seconds with the same data. We just put a little load on it. Whereas if we do it properly with the IQueryable, it stays 130 milliseconds. So now we are having a difference of 260 times faster. And this is sometimes the cost of not understanding what happens behind the scenes and then say, well, it sucks because it doesn't work well. But also another thing here is, after I ran this test, my computer was unresponsive for 10 minutes. And this test only ran 16 seconds. So 60 seconds was enough that I wasn't able to move my mouse for 10 minutes. Just to give you a perspective of how bad this is. To be frank, I did run .NET and SQL Server on the same machine, but still. Now, the other one that some of you might not know, how many of you know S-node tracking? A lot. Awesome. So I'll just quickly skip through because some of you might know quite a lot about EFCore. So S-node tracking, basically what allows you to do is it allows you to not track changes. And why this is important is, think of it, I would almost prefer that this would be called as read-only, because that's what effectively you get, is data from the database that is read-only. And that, the consequence of that is, by default, when we are fetching data from the database, we're generating the query, we get the SQL Server to respond back with the data, we parse, we map the data in EFCore, and then EFCore adds additional properties to track all of your columns and all of your rows. So when you do save changes, it knows what changed. And with the S-node tracking, that doesn't happen. So whatever changes you do, it's not, when you do save changes, they won't be saved. Now, the result of that is you get 4 times less memory usage. In this particular case, this is going to vary a lot. In some of the cases, it's going to be 20%. In some of the cases, it's going to be way more than that. But on average, I've found about 50% less memory usage and also about 50% faster on average from the testing I did. And what is very important here is this is very dependent on the DB provider you use. So at least in EFCore 7, and I think that was a bug, S-node tracking had no effect. So if you used S-node tracking or not, you got the same numbers. And when we start to load test, we're getting about same performance gains. So that's mostly because with this kind of load testing, we're not overloading the system enough where this code would run significantly faster than this one. Usually when you have big disparity between the unoptimized and optimized code is because the unoptimized overuse so much resources that the system is not able to keep up giving and destroying the resources. And for explicit includes, how many use .include? Nice, almost the entire room. Should have prepared a much more advanced talk. So basically, they are, when you use .include, what that allows you to do is just do a join behind the scenes. But there are a few issues with .include. So if you do .include, but you no longer need that, in the mappings you're not using this customer anymore, it will still do a join to that table. So some of you may know that joins in SQL can be very expensive. And now you're doing a join and you do nothing with it. So this is why explicit includes can be many times quite problematic. Sometimes they're necessary, especially if you need to track it and then save it. But if you can, try to avoid it. So for instance, here I have one that has .include. And here I have one that does mapping over here. And you can see that you can just directly map x.sales.firstname. And what it's going to do behind the scenes is it's going to join the table sales and the salesperson for you. You don't have to think about it. And the advantage here is if you no longer need these two lines, that join no longer exists. That join only exists if you use it. And this is the difference. So if I would put in, .include x sales persons here, it will do join no matter what. And of course, you can use other libraries like AutoMapper to do the mapping. I usually like to do it manually just because it gives you a really good view on what data you're fetching. And everyone can look at the code and understand, okay, we're getting sales with salesperson, and all of this data is that we need for whatever we're going to do with this data. And here, again, the performance is going to vary significantly between one and the other queries, how complex the joins are. But generally speaking, you will almost always get a little bit faster performance if you do manual projections, especially if you skip a couple of columns. Then we have common pagination issues. Now, how many of you are confident that you know how to do pagination? Okay, we have only 4 hands. Okay. I'm not too surprised, because this is one of the things where I commonly saw as like, you did the right steps, you just flipped them a little bit wrong. And what usually happens is, they're fetching all of the data with the filter they need to apply. And I was like, why they're doing that? Because they're trying to count the entire, how many items there are. And then they apply pagination in memory. Now, if you have a few hundred or few thousand rows, you probably won't bother with the performance. It works fine. With 7 million records, this is horrible. And this is why software gets slower over time, is because of small things like this. It's what they call death by million cuts. Instead, what you can do is you can use IQueryable over here. And even though it feels a little bit wrong to ask SQL Server, hey, give me a count for this, and then do pagination on the original query and then get the results back. But it turns out this is almost consistently faster even on a smaller size, smaller results. Now, if you have under the page, you can do a little bit more optimizations, like you don't need to do pagination if the count is less than page size and stuff like that. You can squeeze out a little bit more performance out of this. But generally speaking, this is a pattern that you can use for most of the pagination problems. Now, you have another one, some of you might know, is the cursor index in SQL, which is great for infinite scrolling, and is one of the most performant ways for paginations. But usually when you have paged page tables, they don't work really well because the way it works is you need to know the last item from the previous page. But if the table can change over time, or somebody can just modify the number of page they are on, it just doesn't work anymore. Because it's really tightly connected to how you order in the database and knowing what was the last item from the previous page. But in most of the cases, this is good enough performance for most of the cases. But if you really need even more, there's cursor index. And this, of course, massive performance differences, obviously. And also here, because I didn't want to wait for my machine to be available for the next unavailable for the next 10 minutes, this is a smaller size. So this is not 7 million. I think it was 50,000 or something in that ballpark. And you can see it struggled a lot. But when we implemented pagination properly, we were under 100 milliseconds, which is really good. All right. Now, this one, I think a lot of people did not know either. Who knows cancellation tokens? Who actually use them? Okay, almost entire room for knowing that, and half a room using that. How many of you are using it for EF Core? About a quarter. Okay. I think I'll make you use more often in EF Core as well. So what's the problem? Well, let's say somebody DDoS you for whatever reason, or you have just cranky users that smashes F5 a lot, or you get a lot of, say your business becomes really popular and you get lots of requests. What may happen is we get here HTTP request, EF Core does its thing, sends a query to SQL Server, but then you have here a cancel request. Now, this cancel request can actually happen if you have like an Angular application, a Smart application, and you switch from one page to another. And the user just switched from the page away before the request finished. So this can happen more frequently than you may think. But what happens is this is still happening behind the scenes. And not just that. It looks, is it canceled? Well, okay, no, just do the thing normally. But if it is canceled, it will process your code until the first cancellation token it will hit, or it will basically complete the entire request, and then ISP.NET Core will be like, you know what? I actually don't need your response, and then just discard your response. So basically, you've done all of this work for nothing. And if you're under attack, or you're basically having lots of reports that takes 30 seconds to generate, and a manager is very cranky and smashes refresh button lots of times, you're going to have bad time. And SQL Server is going to have a bad time as well. So what you can do is, on all of the requests, you can do cancellation token, and then pass it over here in toList async to first of default async, any async, max async, almost all of the operations that return something from SQL Server will have an async option with a cancellation token. Now, what happens is when we're doing HTTP request, it generates a SQL Server query. It sends it to SQL Server. The user cancels request. We have here a request to cancel the SQL query. And that gets sent to the SQL Server. And SQL Server stops, and also the ISP.NET Core stops. It throws a, I think it task canceled exception, and it stops from where you actually done the query. So the the exception bubbles up, and you then stop processing all of the request. And the benefit of this is, for instance, here we have a similar test here where we just tried to count. And if I remember from the first example, the count was about 130 milliseconds or something like that. It was much, much faster than 10 seconds. And this is what happens when we do the same request under load, where we cancel the request every second. So I think I'd actually done this. Yeah, I actually used the bad example where it takes 3.5 seconds, sorry. Just to make it so that it takes more than 1 second to complete. Now, when we're using cancellation tokens, what you might notice is it's only half. It should have been 3.5 seconds, roughly, from the first example. And it's still not 3.5 seconds. And that's because when we do cancellation, there's still some cleanup to do. The server is still overloaded with data. Like in this case, I'm doing 12 requests in parallel, whereas in all of the other tests, it was 5. But the important part here is this part here was responsive a lot faster than this one. So even when your server can handle the load, for instance, the cleanup, the garbage collection, all of that stuff will make your server more unresponsive, and it will take longer for it to recover from that bigger load than if you use cancellation token. So there's several different benefits to having cancellation token. And last common mistakes that I saw, and this one, to be fair, is very, very recent with EF Core 7. Actually, no, I think they're calling it EF7. I'll need to check the official naming. I think they use sometimes EF Core 7, sometimes EF7, sometimes EF8, EF Core 8, bit mixed. Now, traditionally, what we did, if we wanted to update, say, all of the employees, and here just for fun, what I did is just swap the first name and last name of the employee. Imagine that we're trying to just set everyone to be active, or we want to update something for all of the employees. The way we need to do nowadays, the way we do nowadays is, well, we had to do until now, was get all of the employees we want to update, and then we need to do a for loop, update them, or whatever we want to do with the data, we need to update them like that. And what results is, here is the initial query that gets all of the data, and over here is us updating one employee at a time, which can take a while, especially if you have hundreds of employees. Imagine if we're trying to update all 7 million sales. Say that we want to just say, okay, these 7 million sales are in that text period, and we just want to tick off that we have audited all of them. That'll take a lot of time if you do this approach. Now, what you can do now with EF Core 7 and EF Core 8, you can now just say, execute update, and then say, set this property to last name and last name to first name. Now, you could use an actual string over here or your own variable. This is just me trying to run a test that it can run repeatedly. But this, what allows you to do is, if you already know how you're going to update a specific record in the database, you no longer need to fetch the data and then update it manually in the .NET and then use save changes, which also is a lot more code. And what is also important here, you can do .where over here. And another thing is, you can also use the global query filters. So if you don't want to update employees that were self-deleted, that is all built in. You don't have to think about it. It just works. And if you wonder what is tag width, if you want to know in SQL Server from where that request is coming from, this tag width is included in the SQL query. That means that if you use SQL Profiler, or use Application Insights, Seek, console logging, file logging, whatever, and you're logging your queries, you have now a string that you can directly point to that specific code that executes it. And from EF Core 7 onwards, for the first time, now you can actually also tag with execute updates and deletes, which before wasn't possible. And the performance gains here is, this is only 23 records, but we still get 3 times faster performance. Now, you can imagine how much more that would be if we do, say, with 7 million records. All right. We got 20 minutes, so I have time to talk about more advanced stuff now. We have done some of the common mistakes that I have seen in EF Core. And how many of you found so far useful the advice? OK, practically the entire room. Now we're going to go a little bit more advanced, a little bit off track of common mistakes. So the bonus tips that I have is the other issues that I have seen, other horror stories. And one of them, I seen it last week. Like, I have no words for it, but yeah. And it was kind of like this, but yeah. At least it was an old code base. So what's happening here is this happens more often than I want to admit is when somebody does a to list and then checks if it's more than 0. If you really want to do inefficient but not too horrible, at least use first or default and then check if it's not null. Or just use .any. That's even better. But yet, I actually seen that. And then we have get sales. Now, this is an interesting thing because I didn't know why some people done that until I was trying to talk to them. And what I realized is they didn't know that you could use IQueryable to build a query over time. So what they did is they basically tried to fetch all of the data that they know they might need, and then they, in memory, filtered them out, right? Because they didn't know they can just build a query over time. And by the way, some people use sale ID not equals in the where clause, and then they use, if it's not null, then do this comparison, which is perfectly fine. But if you want to maximize performance, you can also do this. And what that happens is this condition never even reaches SQL Server, which gives you a slight performance boost. And another thing that can also be a benefit is if this where clause happens to have, say, let's say that it would be x.salesperson.name equals to this name, right? If this is in the where clause, it will implicitly join the salesperson table. But you don't want that to happen if you don't want to filter by a person's name. But if you do that, baked it in, that will always happen. So instead, you can do this and not have that condition sent to SQL Server at all, and it will only do join when you need it. All right, how many of you know DB context pool? Only a handful of hands. Now, DB context pool is really cool. Now, Microsoft realized that most people don't know about DB context pool, and they moved a lot of the features to the actual DB providers. So DB providers have connection pool behind the scenes. What that means is when you do a query, it makes a connection to SQL Server, and when it's done with the SQL Server, it does not terminate the connection. It keeps that connection warm. So the next time you ask something from SQL Server, you already have that connection established. So that's what we're getting, I think, from EF-Core 3.1 for free. But what DB context allows us on top of that is for the DB context also be recycled. They basically just reset all of the DB context properties, variables, so you basically get even more performance gain and you get more memory efficiency. Microsoft also recommends this, and what it allows you to do is you can become more scalable because your memory usage doesn't grow as fast with DB context pool. One thing to just keep in mind, if anyone uses dependency injection on DB context pool, this may break it. Or if you have anything that is stateful. Now, one trick that I do is I use this, and I hide the DB context behind an interface. And I do manual resolving of that interface by fetching the cell DB and then populating the injected services in it. That's one way I'm dealing with it, so that I can still get the DB context pool features, but if I have anything stateful, I can control it at the time I need the recycled DB context. Just something to keep in mind. Now, I have shown you get tweets, tag with. This is really cool because you get it into the log. I unfortunately didn't have access to VPN, and also my luggage was lost, and I couldn't get my battery running and all of that stuff. I actually have built now reports where I can just have columns of different tag with queries, and it gives me a chart which of the queries are most problematic. And because I have this comment over here, I know exactly which file to blame. I can just say, this get tweets is okay, but there's a couple of other queries. I can just copy this segment over here, Control-Shift-F, and I get exactly to this query, and then I can address this query specifically. This is very important, especially if you have like random bursts of performance issues, and the performance issues are not too clear. With this, you can try to identify if one of the SQL Server queries is actually making the SQL Server super busy, and then you can start diagnosing that particular query from the get-go. Also, how many of you are using ChatGPT? About half of the room, 3/4. So there's a lot of tips I can give you for ChatGPT, but the simplest one, for sake of time, if you are an EF-Core expert, you are an EF-Core expert and clean code developer. This part here is quite nice. You generally get slightly better code. And you can then write your instructions over here. You can optionally paste DB context. Now, your DB context might be big, so you can just paste a snapshot of that, just small snippets that are important for this prompt. You might want to also add entities. Sometimes it's not necessary to have entities because it can deduce from what you want. And also the return types, because I like most of the data that I get from the database to be already mapped. And what I have here is get all employees' details for each, get statistics on how many products they sold, how much they earned, and list of sales they did, all paginated. Now, this is when you piece together all of the things that I have talked today. This is not too difficult to make, but it may take an hour. You know, you write the thing, you run it, you figure out that, oh, wait, I actually misunderstood how to do that, or, I need to join with this table, not with that. And it can take an hour to build this. Or you can just ask ChatGPT, and in 5 minutes, you get a pretty good code. In this particular case, so in this particular case, it doesn't actually do counts, but it would take you a minute to just make a small refactor to also do the counting. But the cool thing is, you don't have to think about how to build this thing here, and all of that stuff. It just does it for you. So if you're looking for great ChatGPT prompts, and you don't want to remember lots and lots of things, this small snippet here is usually good enough. I would recommend that you run 3 times, because some of the code might be bad, but within 3 runs, it usually gives you a pretty good code. And before we end, I have done this talk, and I've seen some people on YouTube comments saying you shouldn't do premature optimizations and stuff like that. And I added the segments just for that part. And the reason why I wanted to give this is to basically explain when you should actually think about performance. Because, yes, this talk is focused a lot on performance, but it's focused on performance on a very bad cases, where you can very clearly see, hey, it's not just that the code looks a little bit bad and doesn't really do what you intended to do. It actually has major performance side effect. But if you follow best practices, that's not premature optimization. That's just smart programming. When you expect high load, you should talk with your product owner and say, hey, this should be part of acceptance criteria. Because if you know there's going to be 7 million sales and you don't have pagination, that's something that is missing in the task you're doing. That's not trying to prematurely optimize. This is something missing in the specs. And when there's something that already causes performance issues, you should at least make a comment on it, have it in your backlog, know that it exists. Because a lot of time what happens is people just accept that it's slow, and then years pass along, a lot of data accumulates, and at some point there's a tipping point where the server no longer can handle that much scale. Maybe there's some added features, or you just start to reach the maximum RAM. And all of a sudden, that thing starts to become super slow. So what you want to do is basically treat it as technical debt. Have it in the backlog. And never say, we'll fix it later, with no action. It is fine to say we'll fix it later, as long as you comment the code saying, Here is a problem. We need to fix it, and then put it into backlog. Too often, I have seen where it's like, we'll fix it later, and nothing happened. And then 2 years later, it's like, oh yeah, we said we were going to fix that. Usually when it's way too late to fix it. And also, premature optimization is not an excuse for bad code. If you write the bad code, and we all do, I also do, you should at least mark it to be fixed later. There's no excuse to have a bad code in your code base on a long term. Yes, there might be deadlines where, hey, we will lose $1 million if this does not get fixed today, and you basically don't do the best practices that day. But that means that you have a task in your backlog that you fix that problem. Because you don't want to have a problem that will haunt you. Sometimes 15 years later, that's what I'm dealing with today with current client. Problems done 5, 10 years ago. So please fix that. And here are a couple of resources. You can find all of the tests that I've done in EF core sample stability and performance. If anyone wants to dig in, I actually done some SQL versus EF core tests. And if you're interested in, it's about 50% difference in EF core 6. So if you, if you want to optimize a query that runs 80 milliseconds, reducing to 40 milliseconds, that's not really a huge gain, especially because you lose on maintainability, refactoring, the code is a bit harder to read and stuff like that. But there are some cases with that 50% means the difference between running it for 30 seconds or 15 seconds. That's where you want to use, say, raw SQL. Then we have also Microsoft resources. They've done an amazing job with this. Most of the tips are over there. When I started doing this, almost none of this was there. So I'm really proud of Microsoft to take initiative. The only problem, very few know about this link. How many of you knew that? So only a few hands. Then we also have as SSW rules the better entity framework as well as link. I also got inspired a bit from Nick Chapsis on how to do the performance test and stuff like that to show actual impact of decisions. So it's not just use this code, it's better, but saying, hey, use this code because this stats over here, this is what happens if you don't. And I really like that format. So key takeaway, IEnumerable is very dangerous. Use it only when it's intended to be used, when you use EF core. For everything else, IEnumerable is awesome, just not for EF core. As not tracking, you can get almost free performance boost as long the data that you're getting is supposed to be read-only. If it's not, you'll end up with bugs. And simpler code can result in better performance. How many of you seen the code from the bad code and good code and felt the more performant code looks a little bit better? We have a couple of hands. But even if it didn't look a bit better, as long as it's not worse than the original, and you're getting all of these benefits, it is a big win. And I really like to do queries that are concise, performant, and still gives me the flexibility to refactor them. And if I need to comment them, now I use tag with, which now serves not only for me to find the queries in the SQL profiler, but if I had to do a more complex query, it kind of also serves as a comment as well. So it now works as a double duty. You'll be able to find the presentation over here. I'll also make sure that is on the Slack. Wait just a second. Thank you. Now, we have 5 minutes for questions. Yes, question?
Thanks for the sharing as well.
Can somebody bring a mic?
I can try it louder.
Yeah.
Okay. The question is, do we need to call as no tracking if we have the manual projection?
So who do we need to call if we have manual projection? As no tracking. So when you're doing manual projection, as no tracking is implicit. But there is a caveat. But there is a caveat to the manual mapping. Let me try to find one where we have, I think it's, nope, not that one. Come on. Yeah, so here. So what happens is if we do, instead of salesperson first name, if we do salesperson equals X salesperson. Now, I thought that if you don't do as no tracking and you do select, you're good, right? But what I learned is if you don't do as no tracking over here, all of this part here would be untracked. But if you do salesperson equals X salesperson, this salesperson is actually tracked. Yes. Which is why I usually add as no tracking, even if it's technically not required, just in case. Now, in this particular case, yes, as no tracking is a bit redundant, but it might not be. And if you have a big developer team, sometimes it happens that they get an entire table. And it's not necessarily wrong, especially if it's a list and they basically need almost all of the data and it's not something they return back. It's just something they need to do for processing. It's fine. But yeah, it basically causes a problem that it can be tracked. And you can accidentally change salesperson when you didn't intend to. Any other questions? We have over there.
I want to know your view on the lazy loading perspective, like when I'm doing many queries as you were testing. If we can benefit from this, because I had some troubles with lazy loading in the past.
Yes.
And I want to know your thoughts about this, if it's worth or not, and if, how do you see this like in a critical environment of production?
So the question here is how I look lazy loading.
Yeah, I want to know if you think like it's more recommended to work with lazy loading, or if
yeah. To answer your question, try not to use lazy loading ever. In fact, EF Core gets out of the way to make adding lazy loading a bit painful, and I'm grateful for that because. We are currently migrating an application. If anyone is interested in a lot more complex scenarios, we're moving from Entity Framework 6 to EF Core 3.1, because we're moving from .NET Framework to .NET 8, but we cannot move to EF Core 8 right away. We can use 3.1 first. The original code had lazy loading. We had so many issues, and when we fix up the lazy loading, we haven't moved to .NET 8 yet, and people think we have because the application is so much faster. And it was because there is no way to know what thing is lazy loaded and what is not. Now, if you have to deal with a old thing with tag width, when you have to deal with old databases, this thing here, tag width, can help, can save you. Because what happens is, if you have, if you have a lazy loading, or if it has split queries or things like that, that tag width will be in all of the queries related to this. So no matter how many queries EF core will generate as a result of that query, all of them will have the same tag width. And when you have multiple queries with same tag width, with same comment over here, but they're all different, you have a problem. It means that either you have lazy loading or you have query splitting. And the select kind of works as lazy loading because it does implicitly load data. I'll need to click through to that, go that, but if anyone is interested, when you do .select, that can be your alternative to lazy loading because you can just specify all of the data you want ahead of time, and EF core figures out how to build a singular query. I hope that answers the question.
Very good.
All right. Yeah, we have one more question, and probably then we'll have to go for a break. Yeah?
Could you give more information on split queries?
The question is about split queries. So the same way we do S-not tracking, we can also do split query. Now, this I didn't include that because usually this is a more complex problem, where imagine you have a select statement where you have a complex mapping. And that's the way joins works. Say that you have one-to-many. The one, say, salesperson have, say, 100 sales. What happens is that one salesperson gets repeated 100 times because that one salesperson have 100 sales. That's what you're getting. That's the raw data you're getting back from SQL Server. And EF Core basically hides that fact. But what you can achieve with, if you just add as split query, is it can query separately the salesperson and separately sales. Now, in this particular case, the performance gains are minimum. But for instance, if you have a slow connection or things like that, you can still benefit from lower package. But there are cases where you have complex query, where splitting the query have massive improvements. But generally speaking, you want to split queries when you need to. Most of the time, because EF Core is not the best judge on when to split the query. It's a little bit of science and a little bit of magic to figure out when to split query. All right, with that, if you have any questions, I'll be around, and thank you for listening.